Hello and welcome to this Dynaflow Research Group webinar. My name is Luc Hennen and today I will tell you a little bit about how to use ISOtracer to reduce modeling time. ISOtracer is a new software package that Dynaflow Research Group released recently and it helps you to increase effectiveness and reduce cost and therefore money while modeling piping systems. So on this slide, we see some screenshots of the ISOtracer software, but I will be discussing the software and the features in a lot of detail in just a moment. Before I want to go to the actual software, I want to tell a little bit about why we made this software package. And the reason is clear. Every time we did a pipe stress analysis, we started out with modeling the system in a pipe stress analyst software, and every time this took quite a lot of time. And after the project, we came to the stage where we had to mark the isometrics by hand. So you had to draw all the nodes and all the features, all the supporting, and all of this takes time and they are all actions that can be quite easily automated. And from this need, we developed the ISOtracer software tool. So with this software tool, you can model your piping system 50% faster with respect to just doing it by hand, every input. Also, it provides automatic markings, so all the nodes, all the lines, all the values that you set into the software are automatically marked on the isometric. Of course, after you finish the model, you are able to export it to several pipe stress software packages, such that you can start analyzing it. And please note that you can not only export it to stress software packages, but that you can also use it for 1D fluid simulations. For example, the software package BOSfluids that we also release. The ISOtracer software package provides an interactive 3D model. You can see a little bit of that in this screenshot, but in a moment you will see a lot of this. It also allows superior quality control. In the past, I've seen a lot of isometrics marked up by hand that are simply not very clear. You have lines going everywhere, you have numbers written down by different people on these isometrics. And ISOtracer allows you to provide a really good quality marking on these isometrics. And finally, but not least, you can manage your isometrics, your drawings, your drawing number, the sequence, and all these details in ISOtracer. So it allows you for a very good management of all these drawings. Alright, so before going to the software itself, just a little bit about the content of this webinar. Of course, I will be discussing how to use ISOtracer. I will include what the workflow is when using the software package, which modeling and marking features are present in the current edition of the software, and how to export it to the, well, for example, a stress analyst package. Okay, so let's now go to the ISOtracer software itself. So for this webinar, I will simply start a new job, and I will simply step by step on a very slow pace do the different actions that a user would have to perform. So let's name this example. I'm going to use the metric unit system, and I'm going to save it in this directory. Okay, so here we see the ISOtracer interface. first thing we notice is that there are two screens. Well, basically three if you take into account this section. So this section, the left section, is where all the drawing numbers will be. Then in the middle we will have the section where the drawing is displayed, and on the right we have the 3D viewer. Now the starting page already provides a lot of information on how to use this software tool, but for now we can delete it. Delete ISO. Okay, so whenever you would start modeling your piping system, you would simply start by adding new isometrics. Now these example isometrics include two pages. I want to use the user file name and I want to include all of them. All right. Okay, so now it becomes clear what all these different sections in the interface do. Here we have our two isometrics. And you can see that the name of these isometrics is as the file name was. In addition, and an additional number is displayed. Note you can always change all these details. Oh, I don't want to delete it. I want to edit it. So I can always change the name and provide a description if necessary. But for now, let's leave it as it is and go to the markup stage. So now we are in the markup phase of the software, and this allows us to start building the actual model. Now we will start building on this isometric. First thing that you need to do is check if the coordinates of your model are correct with respect to those of the isometric. Now in this case it is already pretty good. All axes are as they should be. If you want to change this, you simply drag the different axes such that it is as you would want it. But for now I just gonna leave it as it was. Now the reason that we have to do this is because the software ISOtracer will automatically detect the direction in which you are modeling. First things first, let's start with the first pipe segment. We have to press this button, start tracing. Note that you can also use the short key T. Once I start tracing, the first thing that the software asks is a node number. So let's start at node number 1000. Okay, we immediately see the following. First we have a circle with the node number in it. Note that it is not displayed very effectively, so we will have to drag it a little bit this way. Okay, and also you see that there's a red line in which you are pointing the pipe. Alright, next node. Okay, so the next node number is displayed automatically as well. And we also see that it automatically jumps to the length. In this case, the length of the piping is 6000. Also, since this is the first pipe segment, we have to input the diameter. Let's take 500 for now. And the thickness, let's just take 10. Alright, so now the first pipe element is defined. And we see that it also is made in the 3D viewer. The length of the pipe is displayed here. Nope, that was not what I wanted to do. The length of the pipe is displayed here, and you can drag that just alongside the pipe. Okay, let's just continue for now. Just continue from here, extend. Okay, so basically I think it becomes clear where a large part of the added value for the software is. You can simply click your way through an isometric and the model is built automatically for the biggest part. So for now, let's just go. This value is 2348. Alright. Note that the direction in which I am modeling is detected automatically. And note also that bends are defined at locations where the direction changes. Okay, so we have to change this first. Okay, and then we can continue. Alright, so especially in these line segments where you can quickly click through your model, you can really quickly define your model and hence save the time to set all these values by yourself, the directions, the handles, etc. Now here we come up at the stage where we come close to the edge of the model, of the isometric. So let's include this final piece. Alright, so now we have to continue at the next isometric. We simply go to the next isometric. This was the connecting pipe segment, and we click here. Now what do we see? We see that there's a label which displays the previous isometric, and we see that the node number 1090 is the same node number as it was here, 1090. Okay, so the pipe simply continues here. Alright, let me just quickly fill in these numbers. Okay, so this is a segment, the next, in which we will have a different angle. Alright, so once I press here, we see that the direction is automatically detected. Alright, so we have to set the length 1588, and we see that 1123 and 1123, which are the components in our coordinate systems, is automatically entered into the right values. Okay, so let's do one like this. Okay, so here we have some valves. So these are not piping components, but valves. Now I see that I forgot to make this look a little better. Okay, so this is a valve, so a rigid component. You can simply select rigid. Note that there's also a short key. You can use the short key P if you want to select piping, and the short key R if you want to select rigid. Okay, so then a short element of 6/8 and another rigid of 1/4. Okay, so these are all rigids. Now I select P, that's the piping system, and I continue to the end. Okay, pressing right mouse button, you leave the tracing mode, and you now see that those two isometric drawings are quite easily turned into a model. So the basic model is there. You see that the rigids are displayed differently than the piping. One interesting feature about this 3D modeler is that it really links the location where you press to the location on isometrics. Now, if you have two isometrics, keeping an overview isn't that difficult. But if you have, say, 50 or 80 isometrics, then it definitely becomes difficult. And this provides a means to really easily go through different sections of your model and take the isometrics in front of you. So if I, for example, select this node, it automatically selects that node in the isometric. While if I select one over here, it goes to the right spot. The same holds if I press on the isometric itself. It locates the right pipe segment in the 3D model. I see this is not a rigid as I want it to be, so let's make it that. Alright. Okay, so next feature is, for example, this T. We now have one chain, as we would call it, and this chain goes all the way from node 1000 here, and then along the piping all the way down towards the end, node number 1230. However, if I would want to have a T, I can, for example, make a different chain. Let's just start isotracing right there. I will call this node 2000. Interesting to note is also that the direction of this node label is kept the same while clicking through the model. Okay, so in this case I would have to move it. 2618. But then for my next instance it is located in the same direction. Okay, so once I press here, it automatically snaps to the node that was already defined there. Alright. And we see that that pipe segment is also included in the model and connected to this node. Now, once you start extending your model and once it becomes very big, these changes have to be managed properly, because once you want to export it to a piping system, piping stress software, then they do not allow for overlap in nodes. So therefore you can go to View, Chain Monitor, and here you see all the nodes that are occupied. So we have one chain going from node 1000 to 1230, and we have one chain going from 2000 to node number 2030. So if these chains would overlap, they would be displayed in red, and you would know that you would have to change the node numbers. So having said that, how to change the node numbers, that can be done as such. If you want to change, for example, these node numbers, you can use the increment option. If I would go from 10 to 100, you automatically see that this 100 is added at all locations. Alright. Finally, one of the features I want to mention is the support feature, because of course if you want to do pipe stress analysis, you also have to include supports in your model. So in order to do this, let's select the support button, also available with the short key S. Okay, so we have to include a new type of support. Let's just choose type Y, so a rest support. Okay, so we now get the options positive. We can apply a connection node, the so-called C node, change the stiffness, provide a gap, or a friction coefficient. So for example, if you only want a rest support, as this one is, let's make it positive and have a friction coefficient of 0.2. Alright. So now if I press here, we see an arrow arising, and we also see that the rest support is displayed in the 3D modeler. So now if we would export this model to a pipe stress package, we would automatically have defined our rest support. Let's include a new one in the X direction in this case. Let's take that one in both directions. Okay, so now we see that we also included the axial stop. And we also see it in the 3D model. Okay. So these are just a brief overview of some of the features. I think that the basic concept is very clear. And I think that it is also not that hard to imagine that if you have a rather large model, and that if you use all these options efficiently, you can just click through your model, use the short keys to change the segment into piping or into rigid elements. You can easily include supporting wherever necessary. All the work regarding the direction and the noding and the marking is done by the software package itself, so you don't even have to use short keys or other actions to get this done. And also the isometric is labeled automatically, so after your analysis you don't have to mark these nodes or change anything to this. Note that you can also you have some more advanced options. You can split change at certain locations if the change turn out to overlap. You can delete these labels if the isometric becomes too crowded. So there are several features, and in the end you can just easily build your model and end up with very neat isometrics as well. Alright, so having said this, let's export this model to, in this case, CAESAR stress software. Okay, so export model. Let's call it example. And let's save it right there. Okay, so we have to select an extension. Now you can use the CAESAR II neutral file. That's what I'm going to do now. But you can also use the BOSfluids or the BOSpulse extension file, which would allow you to open it in for example, BOSfluids for 1D transient software. Okay, yeah, let's override the old one. So again, I'm going to use metric. I myself use CAESAR software version 7. Okay. Okay. So now the CAESAR file is made, and let's just open it in CAESAR. Okay, so there we go. Okay, so in order to do this, we have to go to interfaces, CAESAR II neutral file. And use select the right. Okay, there it is. Convert. Conversion was completed successfully. Do we want to perform another conversion? No. So let's now open the system that we just made. Piping input. Okay, so here we now see the software, the model has opened automatically has been exported automatically to CAESAR. We see that the support is defined as we wanted it, including the friction factor and, well, every other feature if we would have used that. We see that the rigids are defined. I've set the rigid weight. I didn't change that, so it was set to 1 kilogram, so 10 newtons. All of that was exported automatically. Okay, going back to ISOtracer now. So thank you all for listening. Before I conclude this webinar, I would like to tell you that you can always go to the ISOtracer website, isotracer.com. And here you can see some movies, and it is all explained to you step by step. And it also, of course, shows you the details regarding pricing and all different features, and also how to come in contact with us if you have any questions. Okay, so this concludes my webinar. Thank you very much for listening again, and feel free to ask questions if you have any. You can do this using the questions option in the GoToWebinar display. Thank you very much.